the spring of 1962, the Tactical Air Command expressed a desire to install in their F-100 aircraft a new generation of Doppler navigation equipment, a navigation computer, and a Doppler-driven roller map. An agreement for Ryan to provide a navigation set stemmed from the Tactical Air Command's interest in the Ryan AV-4D and its pure CW method of operation. The scope and objectives of the project plans were initiated at Ryan, placing this system's components in a 200-gallon fuel tank. The external installation was selected to minimize modification and rewiring the test aircraft. The pod supplied by the Tactical Air Command will be converted to house the receiver transmitter, converter computer, and high-voltage power supply. In addition, it will contain a Lear vertical gyro and a Ryan telemetry package. The Ryan AV-4D receiver transmitter is highly adaptable. The antenna shroud is trimmed to conform to the contour of the particular application. This flexibility of design permits an almost unlimited variety of confined area capabilities. Upon receipt of the tank, Ryan began making the necessary structural changes. Openings were cut for antenna installation and equipment access. Mounting provisions were made for system racks and telemetering units. All cabling was laced and secured to the interior of the pod. One of two connectors provided a system connection to the F-100 pylon. The other was used for tests. Individual units received a thorough calibration before being integrated into the system. The complete navigation set was then bench tested prior to installation in the pod. Sequential pre-flight testing of the Ryan AV-4D navigation set was accomplished in the Electronics Engineering Laboratory. On the basis of these successful laboratory tests, the tank was secured and readied for Ryan in-flight evaluation. The unit was transported to Ryan's flight test area, where simple connections were made to the company-owned DC-3. Suspended from a specially constructed frame rack, the tank was made secure. Final equipment installation checks were completed. The access covers were attached, and the aircraft was ready for takeoff. This DC-3 is wired and completely instrumented as an electronic flight test bed manned by experienced pilots and engineers. As the aircraft rolls down the runway, the Ryan AV-4D automatically acquires the Doppler signals. One of the outstanding features of this system's ability is to track accurately at very low altitudes. The DC-3 flight test repeatedly confirmed fine system performance, accuracy, and capability in pitch and roll limits on numerous flight legs. Important system performance information was relayed through a telemetering unit in the pod to the Ryan ground receiving station. This mobile unit incorporates a multi-channel recording facility. All information received is recorded on the same magnetic tape, including the voice communication with the aircraft. The simplicity of all Ryan Doppler navigation sets is briefly described in this functional summary. The sets employ continuous wave RF energy at a frequency of 13,300 megacycles. This energy is directed towards the Earth's surface in 3 narrow beams. These beams are directed symmetrically downward and outward in 3 quadrants. Portions of the microwave energy which radiate along each beam are backscattered toward the aircraft. The returned energy is shifted in frequency by an amount which is proportional to the aircraft velocity along the particular beam. The 3 Doppler frequencies are measured and used to compute the aircraft velocity components and navigational data, such as ground speed, ground track, drift angle, and distance traveled. The desired information is displayed on indicators and maps as required. The distinctive features of the Ryan AV-4D navigation set for the F-100 aircraft include pure continuous wave Doppler radar, 3 beams, space duplex, fully contoured, fixed antenna, having no moving parts and requiring no adjustments, built-in self-test features, variety of outputs including ground speed, drift angle, and distances traveled along and across ground track, minimum microwave components, no IF circuits, non-time shared transmission and reception, full data stabilization to correct velocity data for aircraft attitudes, standardization of components and circuits for high-volume, low-cost, efficient production. This new generation of Doppler system is versatile and the lightest yet developed for the military service. It was designed to provide navigation information for fixed-wing tactical fighter-bomber aircraft. The set's power requirements are very low, and like all Ryan navigation systems, it operates on the approved FCC Doppler frequency. Ground speed computations to 1,600 knots are attainable with minor scale factor adjustments. The performance of this system can easily accommodate the operational flight characteristics of the F-100. Its navigation accuracies are limited by other aircraft equipment. The test aircraft was flown to Miramar Naval Air Station in San Diego, California, where the Ryan AV-4D was installed. Upon completion of the system's checkout, the F-100 returned to Nellis Air Force Base to begin the flight evaluation program. The tests were conducted by the Training, Research, and Development Section of the United States Air Force Fighter Weapons School, directed by Major Fred Kyler. The flight test program began during the month of August 1962 under the direction of the project officer, Captain Frank Lethen. An F-100F Tactical Air Command aircraft was selected for the system evaluation. The converted wing tank was mounted at the right inboard station, and an Air Force artist completed the pod. Cockpit instrumentation for these tests included a Doppler set control indicator, the ASN-25 computer group, a Ryan AV ground speed and drift angle indicator, and a band's roller map. This Doppler-driven unit inscribes the aircraft route on a flight chart. Captain Lethen conducted a pre-flight briefing with Major Kyler and Captain Gordon. The operational test plans consisted of numerous navigation flight legs throughout Nevada, Arizona, and extending into Colorado, Texas, Louisiana, and Florida. The F-100 will be flown at different altitudes over most types of terrain. In addition, various aircraft attitudes will be executed to determine pitch and roll limits. With the assistance of Sergeant Lorenz and a predetermined course outlined, Captain Lethen prepares for flight. The pilot ground checks the navigation set by means of a built-in test signal and the ground speed readout. The indications prove all units are functioning properly. The pilot taxis the aircraft to the runway on the first of more than 100 navigation legs to be flown during the test program. The Ryan AV-4D begins driving the roller map and provides accurate velocity information as the F-100 moves down the runway. The Ryan telemetering facility was again utilized at Nellis Air Force Base to monitor all aspects of the Doppler system functions. The performance of the Ryan AV-4D operating at low speeds and low altitudes was unexcelled. Pitch and roll capabilities were shown to be at least 60 degrees, right or left at 25,000 feet, and 45 degrees right or left at 35,000 feet. Tests were conducted to 45,000 feet. The maximum altitude capability was confirmed to be in excess of 70,000 feet for normal level flight. The system continually drove the roller map throughout the flight from takeoff roll to destination touchdown. The average range error was 5/100% of the total distance traveled for navigation legs on which accuracy data was available. The standard deviation was 44/100%. The average angular error was 0.3 degree with a standard deviation of 1 1/2 degrees. At least 1 degree was attributed to the compass system, indicating the fine of the navigation equipment. In a debriefing session, Ryan Engineer Rotundo, Major Kyler, and Headquarters Tactical Air Command Test Supervisor, Lieutenant Colonel Robert Allen, discussed the progress and results of the test. Successful unit compatibility with a particular installation was proven by this pod project. Concurrent with the flight test program at Nellis Air Force Base, Ryan, with the assistance of the aircraft manufacturer, conducted studies for an optimum internal aircraft installation. The results of this thorough investigation determined that the most suitable location for the Ryan AV-4 receiver transmitter was the compartment formerly occupied by the strike camera. Other units can be mounted within close proximity. The installation would require a minimum of airframe modification. The ease of installation of the system is typical of all Ryan AV-4 equipment. This navigation system's design is based on knowledge gained by extensive Ryan experience in the development and production of over 2,000 Doppler radar sets, which are installed in more than 30 different types of aircraft and helicopters. The Ryan AV-4 is ready and suitable for operational use in the F-100 aircraft. The competent evaluation of this system and associated F-100 equipment by the Tactical Air Command's Training, Research, and Development Section was intelligently planned, well conducted, and thorough in scope. Ryan is appreciative of the opportunity to have observed and worked with the airmen of the Tactical Air Command.